again, it's Cliff here from Down Under. Another update from this neck of the woods. Well, lately I've been making more parts for the impact tolerant touch probe, doing a bigger production run of parts and making arbor nuts. This little brass part which has got a slot machined in it, as well as all of the turning and threading work in one operation on Rapidturn. Very interesting little project. Hopefully you'll find it fascinating too. They've got a fine thread and some little drive slots, and I wanted to machine them in a one-step operation, so the finished part came off each time. And of course that presented the challenge of the little drive slots. So I worked out a way to do that. I'll just take you through it now. Okay, so for a bit of a background, first of all let's run the part so you can see roughly what I'm doing. And we're ready to slide the stock through to the tool, ready for the next part. So that's a completely finished part. And I've been really pleased with how Rapidturn has performed. It's produced precision parts that are a good surface finish and a good accurate thread that I can test the fit on a tap, and it's holding tolerance really well. Let's just go through the different stations of the gang tooling. So the first tool, and the stock stop, is a conventional turning tool for turning the outside diameter and facing and chamfering. Then we go over to a slot drill, which produces the roughed out hole. Then we move to a boring bar slash threading tool. And I ground that out of an old blunt 1/2" slot drill or end mill, so it was short and stiff, and just bench ground that to the right angles for a fine metric thread. So after it's roughed out the hole, it bores out and then chamfers the back inside and the front inside, and then it cuts the thread. This is all done on PathPilot's conversational programming. Very easy to build up a program, and a really good facility. After it's cut the thread, it moves forward to the slotting tool, and it's just a piece of 10mm or 3/8 high-speed steel that I ground on the bench grinder to the width of the slot. Just a simple, effectively a little short stubby parting tool. And it takes a whole series of rapid passes, taking off about 3 thou per cut, or about 6/100ths, that's about 2.5 thou or something per cut, and just slots it out. And the advantage of that is that you can produce a finished part completely chamfered and slotted in one operation while I go away and do something else. So I wasn't too worried about the cycle time, as long as it runs unattended. That's the key thing that I'm always harping on about. Of course, these light CNC machines are not designed for that type of load, and the ball screw and nut is certainly not designed for high loads. There'll be a tiny load on a little brass slotting job like that, only a few kilos, well within the range of the ball screw and nut. But you wouldn't want to cut a big hefty slot in steel. You could very quickly overload it and rapidly wear out the ball screw and nut. I have seen some people slotting out some pretty big slots and really loading them up. It didn't look right to me, but they've got away with it. But I'd err on the side of caution and not ever slot a big slot with ball screw and nut on a CNC machine. And I was really pleased with the fit. Able to control the fit very accurately. I noticed that the headstock of Rapidturn does warm up a little bit after a while, and you get a change in the diameter of the ID and the OD of around about 1 to 2 thou, and you need to make an adjustment once the machine's warmed up if you're working to fine tolerances. And those little drive slots are about 1.3 deep and about 1.8 wide, I think. And I wasn't sure whether it would work. I didn't know whether I would be wasting my time trying. I didn't want to have to worry about locking the spindle each time. I wanted it to run automatically, and I was a little bit worried that it would turn the chuck and we'd have an El Cruncho meltdown. And I woke up in the middle of the night and I thought, well, actually, why would it turn the chuck? If it's in the middle, there's not going to be any turning action. It should, in theory, work. But you know what it's like. Theory's one thing, practice is another. Anyway, so the first thing I did was just ground up a tool and tried it. Thought, well, it's going to take me half an hour, maybe an hour to try it. If it works, it'll be brilliant. If it won't, I'll have a broken piece of high-speed steel. It's not the end of the world. And it worked a treat. I've done scores of parts and it hasn't turned in the chuck once. So the system works. Thumbs up. With the gang tooling layout, I've found it really helps to do a quick sketch showing the tools and making little notes on them with details of tool radius, tool type, projection length, and tool numbers, and Y offset positions and that type of thing, so that next time you come to do the job you can set it up much more quickly. The code was produced with PathPilot, and Tormach have done a really good job of this. I used virtually every single conversational facility here to produce that code, and it's really quick and easy because you just produce one bit of code at a time. If you're not familiar with it, they've got this lovely new facility here where each bit of code is summarized in this page, and you can juggle it round, you can insert a file, you can delete a file, and you can build up your code. So what you're doing is you're producing, first of all, one bit of code that might be OD turn, and you face and turn it, and you test it and run that part. And if you're not happy with it, just delete the file, start again, adjust it, change a few parameters, produce the code, run it, and when you're happy with it, save it to file. Then you say the next one, okay, we're going to drill the slop as it was. Or, sorry, we're going to drill the hole. And you produce that bit of code and you run that. So it's an iterative process. You're slowly building up the code in a series of very easy steps. And when you're happy with that bit of code, then you don't post it to file, but you append it to the file. So it goes on the end. And then you can run both those codes. And you carry on right through. And if you have any adjustments you want to make, you can go to Edit, G-Code, come in here, make a few little tweaks around, change a few little minor details, save your file, run it again, and in a matter of, well, let's not exaggerate, but a part like that's fairly complicated. Took me a couple of hours of trial and error to get it running properly. And if that was the first time you're doing it, it might take a bit longer than that. But it's a fairly straightforward, predictable process. It's not as scary as it looks. I know this sounds like an advertisement for Tormach, but it isn't. I'm just enthusiastic about the product. While I'm singing the praises of Rapidturn here, please be aware that that's with the proviso that it's within the field of light work that it's capable of. Obviously, this is not a heavy-duty CNC turning center, but for value for money, it's an impressive little bit of kit. If you're new to Rapidturn and you're considering it as an option, I've done quite a few extensive tests to Rapidturn in a series of videos last year, 2017. Have a look at those and you'll get a better perspective of what it's capable of and what it's not capable of. Well, I've been juggling my machines around, moving them all further to the left and gradually opening up a space. And here we have it. A gap at the end, room for another machine. I wonder if you can guess what it's going to be. I suppose it's pretty predictable, isn't it? No prizes for guessing. So that wraps up yet another video. Thanks for watching, guys. Cheers.